All right, so one of the skills that you're supposed to master is using function notation and identifying domain and range, which you'll find in checkpoint 9 in the back of your book. So here's a problem that kind of illustrates that. G of x is 3 times x plus 2 squared. And when you're being asked to find g of -5, what you're really being asked for there is just to plug in -5 for x into the function that's name is g of x. And so what I'm going to do is I'm going to just plug in a -5 where I see an x, and the rest I'm just going to simplify like normal. So in this problem I would do what's in the parentheses first, and -5 plus 2 is -3, and then remember that the next step is to square. So it's 3 times 9 because I have to do -3 squared first. And the answer to that then is 27. Now, if I kick it up a little bit, this question is asking me to find g of a plus 1. So it's the same concept, but this time you're going to plug in a plus 1 wherever you see an x. So in this problem, I'm going to take 3 times a plus 1, plus 2. So wherever I saw an x before, so let's just rewrite the whole thing first. It was 3 times x plus 2 squared, but instead of writing an x, I'm going to write an a plus 1. So 3 times a plus 1 plus 2 squared. And now just simplify whatever you can. So a plus 1 plus 2 can also be written as a plus 3 squared. And a plus 3 squared, please don't forget that middle term of 6a. And then the last step, of course, is to distribute in the 3. Now, if you don't remember why a plus 3 squared is equal to a squared plus 6a plus 9, remember that you're talking about a plus 3 times a plus 3. For those of you that are a little more visual, you would be talking about a square that sides are a plus 3 by a plus 3. And now if you find the individual area of each of those little squares inside, you'll see it's a squared plus 6a plus 9. Okay, the other problem kind of related to that, remember that g of x as it was defined above is 3 times x plus 2 squared. In this case, they're saying that g of x is equal to 9. So instead of this whole g of x, and some students think of that like it's a y, you're going to plug in a 9. Everything else about the problem stays exactly the same. So the difference is that before I was plugging in for x, but now I'm plugging in for y, or g of x. This problem, to solve it, I wouldn't even expand the x plus 2 squared. I would start by dividing both sides by 3. So I'm going to take a little bit of a shortcut here. And here, you can see that the 3's will cancel. And 9 over 3 is 3. And if 3 is x plus 2 squared, now what you think of is you think, well, what number when I square it gives me 3? And that's not going to be a perfect number. One way that students think about this is they would take the square root of both sides. But remember, it could be positive or negative, because the mere act of squaring it will turn it positive. So x plus 2 is going to equal plus or minus the square root of 3. And then I would just subtract 2 from both sides. So plus or minus the square root of 3 minus 2. And that's how you work that problem out. You can watch the next video for the next concept.